Hi everyone, welcome back to another video of Engineers Academy. So guys, so far in our previous video we have seen the fluid statics, we have seen the different properties of the fluid, we have seen the viscosity, we have seen the different types of fluid flows basically. So guys, over here in this particular video we are dealing with the fluid which is there in motion, that is nothing but the fluid dynamics, and the topics will be covered over here will be the equation of the continuity and the flux, that is nothing but the volumetric flow rate of the flowing fluid. So guys, if you are new to my educational channel over here, Engineers Academy, please click on the subscribe button and please press the bell icon also. So guys, without wasting any time, let's begin with our today's topic, that is nothing but the volumetric flow rate and the equation of the continuity. So guys, over here we are talking about the equation of continuity. Suppose a pipe is there which is having a varying cross section. The diameter at the inlet will be less and the diameter of the outlet will be more, that is it is having a varying cross section, and let's say the fluid which is perfectly incompressible and the fluid which is having less viscosity is like flowing through that particular pipe. The type of flow is the laminar flow. There is no kind of turbulence, there is no kind of disturbance in the flow basically. So the amount of the fluid enters through the inlet will be equal to the amount of the fluid gets discharged, gets thrown out from the outlet of the pipe will be same. So that is nothing but the equation of continuity, or we can call it as that is nothing but the statement of the continuity equation. It means the volume at the inlet will be equals to the volume at the outlet. So guys, now let's derive the equation for this particular statement basically. So let's say this particular pipe is having two sections. First section is there at inlet and the second section is there at outlet basically. The fluid passing through that first section is having the velocity v1, area a1, and let's say the time at which the fluid passes through that particular section is nothing but the t. Similarly, at the outlet also, at that particular section at the outlet, it is having the area a2, the velocity v2, and the time at which the fluid passes through that particular section will be t. So guys, over here we can say that the volume at the inlet will be equals to the the area into the rate of the flow per unit time. The rate of the flow, that is we can call it as that is nothing but the displacement. So over here the displacement is nothing but the d is equals to rate of the flow into time, but over here the rate of the flow is nothing but the velocity. So we can equate the formula in order to get the volume of the fluid at inlet basically. So v1 is equals to this a1 into v1 into t. So that particular a1 is nothing but the area at the inlet, v1 is the velocity at inlet, and the t is nothing but the time. Similarly, we can calculate the volume which at section 2, and that is nothing but the area 2 into velocity 2 into time. So over here the time is the similar phenomenon. Over here the time is the unity over here, so that's why it gets cancelled. So the volume at the entrance will be is equals to the volume at the outlet of the particular pipe. So my formula becomes a1 into v1 is equals to a2 into v2. So this is nothing but the equation of the continuity. So over here the area into velocity at inlet is equals to area into velocity at outlet. So this is nothing but the continuity equation that determines the volume at the inlet will be equals to the volume of the fluid flow at the outlet also. So this particular equation is nothing but the continuity equation, and guys we can calculate the discharge also. So discharge is nothing but the how much amount of the fluid gets transferred, gets traveled at a particular time. So basically the discharge, or else we can call it as the volumetric discharge, is nothing but the v by t. So over here the discharge is nothing but the flux. So over here the flux will be equals to the how much amount of the volume gets traveled at a particular unit time. So that is equals to the flux is equals to the volume divided by time. So over here we have got the volume in the meters cube and the time in seconds basically. So the unit of the flux will be equal to this meter cube per second. So that is nothing but the flux, or we can call it as the volumetric flow rate basically. So we can call it as a flux or else volumetric flow rate. So that is nothing but the meter cube per second. So guys, over here in this particular video we have seen this particular continuity equation, that is equals to A1V1 is equals to A2V2, and the volumetric flow rate, that is nothing but the amount of the fluid flows per unit time basically. So guys, I hope you understand this particular simple equation of continuity and the flux basically. So guys, thank you so much for watching this video. If you having any doubts, any queries, you can comment below, and guys, please do subscribe to my educational channel, Engineers Academy.